Math is math. Okay? So, looking ahead, the Brown worksheet was due last week Thursday. Done with that one. The cream colored packet that you got last Thursday, that is due this Friday. You have a chapter 2 test this Friday. Okay? It's October. We need our second one. Gotta have our second one. Okay? So you've got a homework and a chapter test this week. Yeah, sounds good. Love it. Okay? Today, we're going to graph linear inequalities. That's why we've got the graph paper. Wednesday, we're going to graph absolute value inequalities. We'll have more graph paper. Thursday will be review. Friday we'll do tests. Okay? All right, let's do this. Okay. So, graphing a linear inequality is very much like graphing a linear equality. So that was when we were graphing lines. We had 3 different ways to graph lines. What were they? 3 different methods. No, you're talking forms of lines. Different ways to actually put line to graph. Y equals mx plus b is probably going to be your most common one. Solve for y. M is the slope rise over run. B is the y-intercept. Okay, what's another method? T-chart. And the third method, rarely used. Not a big fan of it. Nope, that's for a function. Intercept method, where you find the x-intercept, we find the y-intercept. Okay, so those 3 methods. Okay, so we're still going to do that. Okay, and you can choose whichever one you want, but there's a kicker now on this one. Okay, so the way that you're probably all going to do it is you're going to want to graph your line y equals mx plus b. I get it. It's the fastest. It's the most efficient. It gets you there the quickest. Okay? All right? But here's the kicker. Here's kicker number 1. Kicker number 1 is the line that you graph on your paper, and this is important, is going to depend upon the inequality. Okay? It's either going to be solid or dashed. It will be solid if we have the equals component with it. It'll be a solid line. So when you go to graph your line, you gotta, tap the brakes a little bit, and you've got to decide if your line's gotta go on dash. Because there's nothing worse than drawing a solid line and then you go, it was supposed to be dashed. And then you got to go through and you got to erase the dash marks into it. Okay? Right? And it'll be dashed if it's just less than or greater than. Okay? So that depends on the inequality. Then, kicker number 2. After you get the line on your graph, now then, you're going to have to shade the appropriate side. Because all of the points, so when we just graph a line, that's only the points that make that equation true. Because we're dealing with an inequality now, we've got a whole region, a whole area, a whole side of our graph that's going to make all of them be true in there. Okay? And the way that we do it is we do it with test points. So we pick a point, and then that's not on our line. Kicker there, it's not on the line. And then it's true or false, and that's going to depend on where it is. Okay? So let's look a little bit at that test point. Okay? So here is my equation. Y is less than or equal to 2x plus 4. Okay? I want to figure out the truthiness on the origin. We'll do the origin first. Okay? So what's going to happen is I'm going to put 0 in for x. And I'm going to put 0 in for y. And I need to know the truthiness of that statement. Okay? 2 times 0 plus 4. 4. So I get 0 is less than or equal to 4. Is that true or is that false? That's true. So then, yes, the origin is part of the solution. Okay. You tell me the truthiness for -2, 10. Same equation. Or excuse me, same inequality. You tell me the truthiness for -2, 10. So we're going to plug in +10 in for y, and then we're going to plug in -2 for x. 2 times -2 is -4. -4 plus 4 is 0. 10 is less than or equal to 0. True or false? That one is a false. So -2, 10 is not a solution. Agree? Right. Let's get into it. Let's do it. Let's graph. Here we go. I want to graph the solution set to y is greater than or equal to -1/2 x minus 3. Okay? So the first thing that I'm going to do is I'm going to, in my brain, I'm going to treat this like y equals -1/2 x minus 3. Okay? What can you tell me about y equals -1/2 x minus 3? We got negative slope, okay? So when we do get to the slope, we're going to go down and right, down and right, down and right. Love it? Phoenix? Y-intercept is -3, so from the origin, I'm going to go down 3. Then we're going to do down 1, right 2, down 1, right 2, and so on and so forth. Okay? Love it? So y-intercept is -3, down 1, right 2. What if I didn't want to go down and to the right? Up and to the left. Okay? Before we draw the actual line, and remember we're using straight edges. I did notice on some of the homeworks from last week that we went away from the whole straight edge portion of it. IDs, edges of phones, bend your paper over, use a folder, etc., use an actual ruler, all that fun stuff. Is this line going to be solid or dashed? Solid, right? Because we have the equals component in the original problem. Okay? Right? So it will be a solid line. Stretching all the way across. Okay? Now, I need to pick a test point. What is the easiest of all of the test points? on the 0. Okay? The only downfall is if you go through the origin, you can't use the origin. Got to be off of your line. Okay? So I'm going to pick the origin because I didn't do it. Now for me, I'm a little bit different, okay? But again, I'm also teaching you the way. I also put a little T or a little star or something where my test point is on my graph. Because if this statement that we come up with here is true, we are going to shade on that side of the graph, wherever that little mark is. If it's false, we're going to shade on the opposite side of the line. Okay? So when I plug that in, I've got 0 greater than or equal to negative 1/2 times 0 minus 3. Negative 1/2 times 0, 0 minus 3, negative 3. Is 0 bigger than or equal to negative 3? Yes, it is. Yep. 0 is bigger than all negative numbers. So that is a true statement. So we need to shade this entire side. If you wanted to get some colored pencils and do some coloring, that's fine. I can color. No? If it was false, then we would have shaded on the other side. Okay? Questions on that? Awesome sauce. You graphed me this one. I get 2/3 x minus 4. Yes? Yeah? Okay. All right. So then that would be y-intercept of negative 4. Slope of 2/3 would be up to right 3. Or down to left 3. Just be there. Solid or dashed line? Dashed line for this one. Did I go through the origin? No, so I'm going to use that as my test point. Two times 0 minus 3 times 0 greater than 12. 0 minus 0 is 0. Is 0 bigger than 12? No, that's false. So because that's false, I'm going to shade on the opposite side of the line.
Yes.
I just found like the S intercept and the Y intercept and then I grabbed it.
Same thing. That's one of the three methods. Yeah. It's one of our three methods.
We did a test when we get back into this.
Original. Go always back to your original. Yep. Yep. Okay. All right. So this week you've got the cream colored packet for your review since it's test week. Okay? So that will encompass everything going forward here. The only ones that you can't do, I mean, you can still probably do it, would be number 13. Number 13 is the only one that you can't do yet. That's what Wednesdays is class is all about. But other than that, we're good to go.